In this video, we're going to start looking at other types of indeterminate forms and how we can use L'Hopital's rule to assist us in evaluating limits of those forms. And the key thing here is that we're going to incorporate some new techniques that will allow us to rewrite our limit back into that traditional 0 over 0 or infinity over infinity form. And so to see this in action, consider the following limits here. Here we have the limit as x approaches 0 from the right of root x times ln x. If we were to naively substitute 0 into this expression here, or take the limit as x approaches 0 from the right, we know that root x is heading towards 0, but ln x is heading towards negative infinity. This is the third of our indeterminate forms. 0 times plus or minus infinity is not a well-defined expression. In some cases, it equals 0. In some cases, it equals infinity. And in other cases, it could equal really any real number. So this is another example where we will need to use caution and carefully apply L'Hopital's rule. The trick here is that we are going to rewrite this product of f times g as a quotient. And so rather than view this as the product f times g, we will rewrite this as either f divided by 1 over g or g divided by 1 over f. We'll just pick whatever is the easiest to work with. Note that by rewriting our expression in this form, we will have a new indeterminate form of either 0 over 0 or infinity over infinity. So returning back to our earlier example, we will rewrite this as follows. We'll choose to leave the ln x in the numerator because it is much easier to differentiate 1 over root x than it is to differentiate 1 over ln x. Remember, we know in applying L'Hopital's rule that we are going to need to differentiate the numerator and denominator separately. And so we want to try to keep our functions as simple and easy to evaluate or differentiate as possible. So differentiating each of these, we know ln x will differentiate to 1 over x, and we can rewrite 1 over root x as x to the negative 1/2 and differentiate this using the power rule, giving us negative 1/2 x to the negative 3/2. We can simplify this expression now. Down to negative 2 root x. And this new function now evaluates rather nicely. As we approach 0 from the right, this new function is clearly approaching 0. And so we can say that the original limit also equals 0. So in this example, we did something very similar to the previous examples. We just had to do one initial step to convert that 0 times infinity indeterminate form into a L'Hopital problem. We rewrote our expression as one of our functions divided by 1 over the other. Again, we chose root x to go in the denominator in this case because it was simpler to differentiate.